Okay, this screencast is on matrices. It's well, the introduction to matrices and the first couple of basic operations with matrices, addition, subtraction, etc. Matrices are a fairly straightforward concept. It's a new topic, so let's get underway with it. Matrices being our heading. Now, a matrix is essentially a way of representing data, a way of storing data, and there are a whole bunch of things we can do with it, but it actually has quite a few uses in real life when it comes to data analysis of any type. So we're gonna start off by talking about what a matrix is, and essentially it's a matrices will have matrices are defined. How can I put this? Defined by their numbers of rows and columns, I think is the first thing we should say, and that means that i.e. a 3 by 2 matrix has 3 rows and 2 columns. I know this is fascinating, but it actually is quite important that we are able to differentiate between our rows and columns. A 3 by 2 matrix will look like this. So, e.g., we'll call it A. Matrix A. It's got 3, so it's 3 rows. So 1, 2, 3 rows and 2 columns. So let's get some numbers in there. So we've only got 2 columns. So that's there's our 2 columns. 0, 5. Say that's our A matrix. And let's bring in another matrix. Let's go for a 2 by 1 matrix, which we're going to call B. B is a 2 by 1 with elements 4 and minus 1 in it. Okay, so A is a 3 by 2. That's a 3 by 2. And B is a 2 by 1. It's got 2 rows and 1 column. Okay. Excellent. So first things first, rows and columns in that order. So if a 4 by 1 is 4 rows, another example, a 4 by 1 matrix has 4 rows and 1 column. So what will that look like? It'll go, it's got 4 rows, just 1 column, so it'll just be 1, 2, 3, 4, like that. Let's have a look at another example. A 1 by 2 matrix has 1 row and 2 columns. Columns, 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 columns. Alright, so that will be 1, 2. 1 row, 2 columns. That's it. Okay, a square matrix has the same number of rows and columns. That's fairly self-explanatory, I think. Okay, so that's the rows and columns thing. Let's do some basic addition. Now, addition and subtraction. Let's just have a little heading here. Addition and subtraction. Now, if you're adding and subtracting matrices, they've got to have the same dimensions. So you can add and subtract matrices with the same dimensions. So, e.g., if we're going to add 0, 2, minus 1, 3, if that's my A, and B is another 2 by 2 matrix, 1, minus 3, 4, 2, and let's say C is a, let's get a row matrix in there, 0, 1, Now we can work out what a plus b is because they've got the same dimensions. They're both 2 by 2s. Okay, so let's just get this right. So this a is a 2 by 2, b is a 2 by 2. That's lovely. C, that's a 2 by 1, not a 1 by 2, a 2 by 1, 2 rows, 1 column. Okay, so we can find a plus b. B plus a is the same. As a plus b. Doesn't work with all things, but with addition, yes. We can find a plus b, but not a plus c, because they are not the same dimensions. Right, so let's find a plus b then. So a plus b, well, how do we do it? Well, it's just as you'd imagine, really. What would you think you'd do? 0 plus 1 in the first spot, 2 minus 3 in the second, in that slot, minus 1 plus 4 down here. So we find the result by just adding the elements. So we don't. I did that so that you could see the operations. You don't need to do that in future. Your result is that there. That's a plus b. That wasn't difficult. A minus b. A minus b. That's going to be 0 minus 1. 2 minus 3. Minus 1 minus 4. 3 minus 2. So we've got minus 1 here, 5 here, minus 5 here, and 1 there. Okay, so adding, subtracting must be the same dimensions. Let's have a look at multiplying. So multiplying by what's called a scalar. This will be our last little bit, I think, and then I'll multiplying by a scalar. So, for example, with our, let's say a equals 2, 3, 5 minus 2, then we can say therefore 3a. Now that 3 is what's called a scalar. It's a number that's that you multiply the matrix by. So and predictably 3a is 3 times 2, 3 times 3, 3 times 5. You just multiply each of those numbers by 3. So that's fairly straightforward and logical and predictable. There's our result of multiplying by a scalar. Scalar can obviously be negative. And there we are. Okay, I think that's probably enough for one YouTube. See you in class tomorrow. We can work all the way up to, well, we can do exercise 3A and 3B. So we'll look forward to that tomorrow. Cheers.